A specific heat capacity. You got that? Yeah. Let's see what this is. So, why does metal feel colder than plastic? Or why does water at 10 Celsius feel colder than air at 1 Celsius? Now think about this. If I ask you to sit in water at 10 Celsius, or stand in a room or outside where the temperature is 1 Celsius, which would you prefer to do? Yeah, but this might seem a bit strange because outside is colder than the water, but the water will feel colder. And anyways, why does metal feel colder? Like if I have a piece of metal at 10 Celsius and a piece of plastic at 10 Celsius and I hold both of them in my hands, the metal will feel colder than the plastic, even though they're both 10 Celsius. So what is going on here? Does anybody know actually?
Because metal, it's easy to feel the metal on the metal.
She might have it. Let's see what she has to say, yes?
Because there are different materials.
Yeah, but what? That's the key word, conductor, yeah. So the metal is a conductor. What this means is it's very easy for it to take the heat from your hand, which gives you the cold feeling. The water is a better conductor than the air, so the water can take your heat from your body quicker. Different materials can do this at different rates, with different levels. So a metal is actually very good at taking heat. A plastic is an insulator, it will not take the heat as quickly. Temperature is not enough, that's the point. There's something else. Some materials warm up faster than others. So if you have a fire and you put plastic on the fire or you put metal over the fire, which will get hotter quicker? Again, the metal, because it's a conductor. In other words, different materials have different capabilities when it comes to absorbing heat and increasing their temperature. So we have this concept called specific heat capacity. In other words, it's how quickly the material can take the heat energy. So the definition of specific heat capacity of a material is the amount of energy it needs to increase its temperature by 1 unit, if its mass is 1 unit. So how much energy you need to cause an increase of 1 unit of temperature per 1 unit of mass. That's called the heat capacity. This is the formal definition, which is a very common definition in the exam. Very common. There are 2 definitions in this whole materials chapter, and they're very common for the exam. This is one of the 2 common definitions. The other one we'll do later in the chapter. Got that? Yeah. Now, let me ask you this. If you think about a metal that increases its temperature quickly, do you think that has a big or a small heat capacity? Has a small heat capacity. It does not need much energy to increase its temperature by 1 degree. So the small heat capacity means that the temperature can increase quickly because it only needs a little energy and the temperature starts to go up. A big heat capacity means it needs to take lots of energy before the temperature starts to rise. What are the units? Well, we kind of work out the units here. It's how much energy you need to increase 1 unit mass by 1 unit of temperature. So what could the units be for heat capacity? Well, firstly, it's an amount of energy, so it's joules. And it's to raise it per unit mass and per temperature. Yeah, so it's joules per kilogram per Kelvin. Yeah. So if you want to write it down, the units are like this: joules per Kelvin per kilogram. Of course, if you like, you can even use Celsius. Not Celsius. You could even say joules per Celsius per kilogram. And sometimes it's appropriate to use joules per Celsius per gram. Although I think most of the time this is used in the exams. And these are basically the same thing. You just have to be careful here because the kilo is missing. Okay, so you can actually then use this to get the formula. How much energy do you need to increase the temperature? Well, the formula, it depends on the mass and how much temperature change you want. But simply put, the energy you require will equal the mass of the material times the capacity of the material times how much increase in temperature you want. So, as you can see, if you have more mass, then you need more energy. If you want more of an increase in the temperature, then you need more energy. If the heat capacity is bigger of the material, then you'll need more energy. This is the formula to calculate the required energy to increase by a required temperature change. Delta theta is the change in the temperature. Do you understand what I mean by that? The extra temperature, the gain. Got that? Got that? Yeah? Okay. So we have to talk about what are the values for different materials. So, let's start off with water. Water has a huge heat capacity, 4,181. What does this mean? It means if you have 1 kilogram of water, now 1 kilogram is not a lot, 1 kilogram is only 1 litre, so this here is, this would only be when it's full half a kilogram. So let's say we had 1 litre, so we had 2 of these, and I wanted to increase the temperature by just 1 degree, just 1 degree Celsius, then I will need 4,181 joules to make this only 1 degree warmer. It's not much, but you need a lot of energy to do it. Yeah? Water is quite special because of this high value. This is not normal. Next material, you'll see why. Ice. Now this seems very strange, doesn't it? Ice is water, but it's in a solid. And look how different it is. For ice, you need half the amount of energy to have the same change of temperature. If you really think about it, it's quite strange. Like it's still water, but it's in a different form, and this is enough to cause a 50% change in its ability to take heat. It's about the same when it's steam. It's about 2,000 as well. Okay, now let's go away from water. So, copper only needs 385 joules to increase a kilogram of copper by 1 degree. Next is milk. I don't know why I put in milk. 2,850. Oh, I think I know why. I have a cappuccino question in the homework, I think. Next one, alcohol. And again, that comes up in one of the cappuccino questions, I think. Okay, next. Lead. You know this material, lead? PB? Yeah. Look how small that is. Only 129 joules. So if you have 129 joules of energy, you can increase a kilogram of lead by 1 degree. Compare that with water, and you can see that lead will get hot very quickly compared to water. And finally, air is actually pretty big, 1,000 roughly joules required to heat a kilogram of air by 1 degree. Okay, so once you write that table down, yeah, that's a good midpoint. We'll split this lesson into 2 halves, and we'll continue this in the next class then, okay? Alright. Can I close this now?
Yep.
Yep.